Hello, everyone. Welcome to our webinar. Today, we're going to be going over the Creo Ansys Simulation extension in Creo 7.0.2.0. I'll give a couple more seconds for everyone to join in. While that's going on, I want to get a couple housekeeping things out of the way. You are all muted for the duration of this webinar. That's by design. If you have questions during any of it, you can either put them in the questions panel or in the chat. We'll be reading both. So if you have questions, put them in as they come. I'll answer them probably towards the end of the webinar, unless they're just directly pertinent. Then I'll answer them as we see them. And yeah, so we're going to get started with the webinar now. So what we're going to talk about, like I said, is the Creo Ansys Simulation tool that was just introduced in Creo 7.0.2.0. So we're going to go over a little bit of an introduction to boundary systems and myself, and then we're going to go over the topics you see on the screen, really just kind of overview what PTC simulation products are looking like right now, an overview to Creo Ansys, and then a live demonstration of the product. See a question about audio. It should be coming through, so please check your own device settings. It looks like it's coming through, and I've confirmed that it is. So yeah, check your device settings there. So introduction to myself. My name is Anthony Vetterini. I'm a technical specialist with Boundary Systems. A little bit of background on myself is I have a Bachelor's of Science in Engineering from Case Western Reserve in Aerospace and Mechanical Engineering. I have about 3.5, 4 years going on working with CAD and FEA tools. So I have a good experience with these types of tools. Now to talk about Boundary Systems, we see ourselves as a technology leader. We partner with companies like PTC, e.t.c, and others to bring engineering software to companies. We're the number 16 fastest growing private company in the greater Cleveland area, which is where we're headquartered. But as part of being a part of the PDS Vision group, we are part of a global reach, which you can see in the map on the right. In terms of capabilities, we do quite a bit. We do product life cycle management, PLM, CAD design and consulting, simulation, which we'll talk about mainly today, amongst everything else you see on the screen. A little bit more about us. We've been noted in the Inc. 5000, which is a national, and the Weatherhead 100, which is a local Cleveland measurement of companies. So you have those industry awards. We're also a PTC Platinum partner, which gives us greater capabilities working with PTC and bringing their products to you, along with everything else you see there. And as part of that PTC Platinum partnership, we work with these other software companies, being Tecton, e.t.c, Keyshot, to name a few, Cymerics, which is flow analysis. So yeah, we do quite a bit. We work with a good amount of companies to bring software to whatever your needs are. So now I'll talk about this product, being Creo Ansys Simulation. It's part of an ever-growing product line regarding simulation products. Literally just a couple years ago, 3 or 4 years ago, all Creo or all PTC was really offering was Creo Simulate and Creo Simulate Advanced. Those were pretty much the staples of simulation software for PTC. But as of today, so in the last couple of years, not only do we have Creo Simulate and Creo Simulate Advanced, but through the partnership with Ansys, they brought Creo Simulate Live, Creo Ansys Simulation. We also have Creo Flow Analysis, which is a real-time or a CFD tool, and a generative topology optimization software. So the simulation product line is growing. This is a key area of PTC and somewhere that a lot of products are coming in, with this newest one being down here at the bottom, Creo Ansys Simulation. I'll talk about an overview of it. This is another extension product from the e.t.c ANSYS relationship. So the first was Creo Simulate Live, and now we have this tool. It doesn't come standard with Creo. It is an additional product that is available for purchase, but it is a product that comes from this relationship. This tool uses the ANSYS Discovery or the AIM product line, if you're familiar with ANSYS products. So that's where this kind of tool stems from. The big thing to note also is that it is an H-element simulation tool. So if you're familiar with Creo Simulate, that is a P-element. This is an H-element simulation tool. This is a CPU-based tool. So if you're familiar with Creo Simulation Live, we know that we need a CUDA-based graphics card. This tool does not require that. It is a CPU-based tool. In terms of a solver, it uses a 2 to 4 core parallel solution solver. It's adaptive, so it will start using 2 cores. And depending on your simulation, the complexity of it, it might go up to and use 4 cores. In terms of current support, the tool is a little bit more restricted currently. It has some structural thermal modal support, but this is a tool that e.t.c and ANSYS are actively working on, and there's going to be many more features added on to make it a more holistic simulation tool moving forward. Which brings us into a demonstration, so we can kind of talk about and look through this tool, really get to see it in action. So let me come into this. Okay. Just check any questions. Yep. Okay, cool. So here I just have a single part, little bracket, and I'm just going to come into ANSYS Simulation, which is a new tool. We're going to create a structural simulation. And what we'll see is that it kind of looks similar to Creo Simulate Live in terms of looks. It just looks like it has more features, which we're going to step through here. We're warned in our study about what's going on. So we see little warning labels, which essentially is telling us, hey, our simulation isn't set up. You also have like a study check, which can tell us. So this is a nice feature that Creo ANSYS Simulation has, where it kind of tells you what you need to do to get to a model that can be simulated. So going to add some loads and constraints. Oh, unlock. So we have a load and constraint here, which are just right here. We can add a material with this next button over. And this will also use the material that is assigned at the body level. So we see we have one body, which is part of the Creo 7, the multi-body design. It will take that material for the material assignment. We can start the run here. I'm first going to come check the Refine Model tab. So again, this is something similar to Creo Simulation, where we have some idealizations. What you might know is that we're missing a couple, being the fastener idealizations, which are not in, and the weighted and rigid links. Those have been replaced with joints. And what joints let you do is basically connect things as a specific joint, which is basically freeing or fixing specific degrees of freedom. So there are some defaults, and there are the ability for you to create your own as well. And we also have contacts. Contacts in Creo Ansys Simulation are similar to interfaces in Simulate, where we have bonded and no separation. So we don't have any contact or friction interface. Those are also part of this whole joint connection. And then we have mesh control, which is what I'm going to focus on here. So our mesh resolution, we could change our mesh. We also have mesh size options. So I'm going to first do is just generate a mesh to see what it looks like on our model. So when we press generate mesh, we see down at the bottom, we see a process manager of the mesh. And we see a little icon showing that it is meshing. We could open it and see what's happening. So this took 8 seconds to run. So we're given some time of running. We can display our mesh, and we can analyze it from there. With this mesh shown or unshown, we can kind of come in then and change some of our mesh size functionalities. You know, lower this maximum size maybe down to 12. And let's just turn the resolution all the way to high. And then generate the mesh. And when we generate a mesh here, like it does in Simulate, this will be the mesh it uses for our simulation. And so looks like it just finished. And we can see a much more refined mesh now, specifically around like tight edges and things. So good meshing, quick, nice, less buttons to use, but you have more control over everything. So now if we want to run our simulation, actually, I'm going to turn off our display. We can run, and what this will do, we'll run a simulation, get us our results. And what we'll see is by default, we're given some basic results from Creo Ansys Simulation. So this will include looking at our von Mises stress and our displacements. There. So the basic results, so we could activate our results and look at things like our von Mises stress. With our legend here, we can look at our displacement. In our legend, we could quickly change between units and our measurement. So if we want to go back to von Mises and look at megapascal, we could do that and see the changes. Here, we see a little icon. Here's where we could turn on things like isosurfaces. Concerned with that. Or we could turn off the results window. What we can also do is create advanced results. So if we want to look at and animate the displacement of our part, we could create a displacement magnitude. And what this will do, we'll create an advanced chart. And now we see our ANSYS window says, hey, we need to update our results. So we can right click and update. This will actually update our results. And let's activate our displacement magnitude. And now we see our deformed shape, which we can show using an animation. And we also see the original outline, so we could see it deforming. Play with speed. Stop it wherever we'd like. Again, we could change units. Here we see we can only stay in the displacement magnitude. That's because I'm in the advanced result. So we can't change between advanced and basic results. Last thing I want to do is kind of show how quickly the mesh can update inside of Creo Simulation or Creo Ansys Simulation. So if we close out this tool and then just come into here and just move these, and let's just move them, out this way a bit. What we'll see inside of Creo Ansys Simulation is that we have a little yellow flag now, which is essentially warning us that our simulation is out of date and that we've added or changed geometry in our model. So what we would have to do is rerun the simulation, which I can just click run here, and it'll run the mesher using whatever mesh settings I've most recently left in the refined model mesher. And we'll see that everything else stays the same. So we didn't have to redefine our advanced result. We got that along with our other basic results. So we could activate and come look at our displacement, for example, here. We also have the ability to control our legend, being our min and max. I could turn on bands or have a continuous tone, depending on how that is. Last thing I want to talk about is our probing. So probes are similar to measures from Creo Simulate, where you can kind of monitor things. These are really nice to use. So for example, we can maintain the max von Mises stress in megapascal, and we could take, like, for example, the maximum on a surface. What we'll see is it says not calculated because we haven't calculated. We'd have to rerun the simulation, and these show up in our simulation tree, and you could rename these. Some other options we could do a value at a point, so we could just select a very specific point, or we could take like the average value if that's something you're interested in. So a whole bunch of options there. And again, after you place them, you will have to rerun it. We'll do now to actually get this value to be calculated. So we see the simulation has run, and now the probe is updated. So now we have the maximum von Mises stress on that surface, which we'll see aligns with our maximum von Mises stress because it's located about right here. That's a little bit of a show into the tool, some of the quick aspects of it, and now we want to see, let's see a bigger model. How does this thing handle assemblies? So I will close out of this and open up this bike frame assembly. So what we have here is like a motorcycle bike frame, right? If you look in the structure study, we see we have some constraints where we've fixed ends of the bike. We've placed loads signifying where humans might be sitting, and we've distributed the load across a couple spots. Where the engine is, and selected multiple surfaces. We're saying 600 newtons of force, along with some fuel tank stuff pulling down. Maybe it's bolted in 2 different spots. So we have a bunch of loads and some constraints. The next thing we'll talk about is bonded interfaces. So if we go back to where we started to adding a simulation, we have this option to turn on automatic detection. And if we do that, what Creo Ansys Simulation is going to do is going to look at the connections between our parts in our assembly and create essentially bonded references so that in the simulation, we're seeing them as like super glued or like directly welded together. So we're saying that these parts will not break apart. So bonded is the default interface there. And we'll give this a couple more seconds to find all the contacts. So this is just a second quick study, and we see that they're all put into here. If we click on them individually, we'll see what they are connecting. I'm going to go back to our first study and delete the second one real quick. We can also get to that automatic detection and change it by coming to a refined model and changing this from bonded to no separation. So we could change the default behavior. We also have some defined joints in our model. So again, these are kind of showing how things are held together in place. So we're saying there's a hinge here. It's going to be the same for most of these axes. That's all under the hinge. We also have a translational. So we're saying the shocks are moving down, shock tubes. So when we're pushing a force down, we're saying how these shocks are going to move. So we're basically simulating how things are moving. So these are similar to a contact interface in Creo Simulate, where we're basically saying how this model can move. Again, we have some results. So by basic results, we have our full model is taken into account. Every body in our part, or every part in our assembly is taken into account. And again, we could change between all of our basic results right in the legend and leave here. However, if we created advanced results, so if I look at the definition of this, I actually just looked at, oh, that's all stresses. I want to look at the frame stress. I just selected the subassembly that has the direct frame of our assembly, so it doesn't have anything else inside of it. So all those other parts will be ignored in that result. So if I activate this, we're only looking at the stresses on our frame subassembly. Everywhere else, we are not looking at those results. They're kind of hidden, lined out. We're still showing things like maximum stresses on our full assembly, so we see that's still up here. So it's not going to show us that on this view. But we can come in and change values, of our legend if we're very curious with certain areas. We'll see part of it has disappeared. That's because that's below the minimum, which is a feature inside of Creo Ansys Simulation. We can also show displacement. And again, this is going to show an animated version. So I'll show the all. Give it a moment. And if we animate it, we'll see those joints really matter here because we'll see the shock tubes are basically moving down inside of where we prescribed that they can move. We can see that over here as well. So this one's a good view because we have a hinge support as well as this pushing down. And we see how that all works together because we prescribed that in our simulation. I'll close this again to exit the result. Our final thing is that these results can also be launched in an auxiliary window. And so we could see pretty much the same things except inside of a separate window. Icons might be a bit easier to use here. Close this. That pretty much brings me to the end of kind of just showing an introduction to our Creo Ansys simulation tool and what is now available in it. So I'm going to close this, come back here, slideshow. And so the next thing we'll talk about is a class we're doing. We are having a class for Introduction to Creo Ansys Simulation. The tentative dates right now are March 8th to 10th of next year. So we will be doing a course to kind of go over this tool much more in depth. And we also have future webinars planned on this topic, kind of go over further aspects of it. So now what we'd like to do is kind of open the floor to any questions we have regarding this software. I also want to give my name and email if you have questions down the road. Our sales, specifically if you're interested in this training also, you can email sales about this or just the tool in general. We also have our website, which you can use to sign up for the class and also look at other aspects we do. And also we have a YouTube channel where this webinar, along with every webinar we've done in the past, will be uploaded. So you can rewatch things. And if you rewatch it and then have a question, again, you're free to email me and I can reach back out to you. And so, yeah, that was our webinar on Creo Ansys Simulation. And now I'd like to open it to any questions. 2 seconds. So the first question I see are, what are the main differences, advantages to ANSYS Simulation versus Creo Simulate? So, that's a pretty exhaustive list and something we'll be actually doing like a more full holistic webinar on. To give a couple, this tool is an H element simulation tool. Creo Simulate is a P element tool. So that is one bigger difference. The second is the concept of future enhancements. So an advantage to Creo Ansys Simulation is that since this is a new product, as part of this ANSYS and e.t.c partnership, there's going to be more additional features. This is kind of their forefront of the simulation tool. Creo Simulate is not going anywhere. They're keeping the software. However, much more of their e.t.c's focus is on this tool, and more enhancements will be coming here. So what is meant by H elements? So that's more of kind of an FEA question. It's kind of to describe this H element and P element, which is how essentially your model, your simulation works. Does ANSYS Simulate allow for frictional surfaces? Not currently. There's not any frictional surfacing or any contact interfaces with friction. We do have the joints, which is a similar option. However, we don't have any of the friction options yet. We do have the ability, if I come into this model real quick. We do have the option for frictionless displacement, but we do not have like contact friction yet. We just have the ability to add joints, which essentially not prescribe motion, but restrict how motion can happen given a loading scheme. But we do still have things like displacement constraints. So if you wanted to say the bottom of the shock tube moved 5 millimeters in Z, you could still do that. The next question, a big one I wanted to emphasize is this ANSYS simulation tool standard with Creo 7020? And that's no. This is an additional product that needs to be purchased. But this Creo 7020 is what is needed to run the software. So this is only available in Creo 7.0.2. Another question is, can you save results between different iterations of the model? So what you are able to do is when you save your simulation, it saves to a .apr file. So if I do file, save as, save simulation data, it saves as an ANSYS project file. And you can then go in, make design changes, and save another APR file. Also, we have the ability to export to ANSYS Mechanical. So if that is a tool you use, we do have this ability with the tool. Question about can pretension be applied to bolts, etc. So if you're familiar with like the fasteners in Creo Simulate, we were able to do that inside of there. Right now, we do not have that functionality inside of Creo Ansys Simulation. Another question is, can you run fatigue? That is a functionality that's planned for release in the future and is also not yet available. So not yet, but that is coming. And again, this is a product that is being actively developed. And so new functionalities will be coming very soon. See, one moment. There's one or two questions that I will reach out regarding, so I can check in and confirm an answer to. Len Hensel, if you could kind of clarify that question. I think what you might mean, So if we come into this model, applications, ANSYS simulation. So if we didn't want to apply a load to this whole surface, what we could do instead is we could still apply surface regions. And we can define a sketch and say, let's just grab some references real quick. Let's just say our load is just going to be right here. We could change our force to only be in that zone using a surface region. Yeah, okay, so that's what's your question. Yeah, so you can use surface regions to specify where the load is being applied, and you can further refine how the load is applied. And that goes for any of these types, except for like gravity, that's applied to the whole model. Same thing. But like force, pressure, moment, we can apply to specific surfaces using our surface regions in our refined model tab. Another question is, how does this tool handle the welds and or spot welds? So that is not yet available. We do have shell elements, but there is no weld feature currently in the tool. So those are not handled in this current version. Make sure not. So that seems like it's all the questions. I'll give it a couple more minutes to see if we do any. And if you have any questions down the road, again, here's my email. Yeah. Oh yeah. The question there is, can the reaction and moment be extracted from the analysis? So in this define results, if I come to other and miscellaneous, we have reaction forces that we can measure. So we can measure the reaction forces on certain faces. But not any moments. So just the, oh, sorry, yeah, force and moment reactions. Sorry, they're right here. My bad. Yeah, those can be created using our contour plots. So, and those show up as advanced results. So if I say our moment reaction, just say, okay, we'll see that those show up underneath our advanced results. Okay. All right, and that looks like it's the end of all our questions. So again, if you have any further, my email's here. And again, this webinar will be uploaded to our YouTube channel. So one last question I'll do before we leave. So every time I add a new value I'm interested in, I have to rerun the simulation. Yes, and that's true for a lot of softwares. You know, if you don't, or at least in this case, you have to define your results, then run your simulation. It doesn't calculate everything for you. You can just come in here and refresh. I changed my geometry, so I can't show this. But you can just refresh results, and that will recalculate them without rerunning the whole simulation, which I showed a little bit earlier in the video webinar. And yeah. So I guess not rerunning, but you have to at least refresh your results. And yeah, okay. So if I didn't get your question, as one or two of them, I will be reaching out after this webinar with a more direct response once I can confirm it. And yeah. Oh, okay. We're getting more questions. I'll keep doing these as we get them. Can you run ANSYS Simulate as a background task? So when you run it, it just runs in the Creo Process Manager. You can't like run this and then go start editing geometry or things, but it will just run on the model you have loaded in Creo. And yeah, the other question from Andres, I will reach out to you about your questions. I was a little bit more involved. Okay. Another question is, when is Creo 7.0.2 available? And it is available now. I think it was available last week on November 11th. And it is available for download now from e.t.c's website. And if that's something you would like assistance with, you can also reach out to us. We're always free to help out with those types of things, get you updated. Okay, awesome. So yeah, it looks like the end of the questions. So I'm gonna close out the webinar. Thank you all for attending. Pleasure kind of presenting this new tool we have. And again, if you have any further questions, please reach out to my email there. And have a good rest of your day.